Hello and welcome back to the succeeding session on Chandrayaan-3. So here we will specifically talk about the scientific aspect of the mission, and so here we go. We have divided the mission aspects or all the dimensions into the following flow chart. So here we start with the mission and the rocket that was used, the LVM-3. This is a different model. Earlier, the workhorse of ISRO, the PSLV, or for that matter, the heavier one, GSLV, was used in other missions. But here, this is the rocket with the highest capacity. It's the biggest rocket that ISRO right now has, LVM-3. And V, it's for Vikram. Everybody knows Vikram and Pragyan. That's why I have just mentioned the alphabets. This is the lander and this is the rover. Rover means that will rove around, the vehicle that roves around the surface of the moon near the South Pole. Then, and one more aspect is important. How Chandrayaan-2, the modules of Chandrayaan-2 also had an orbiter. Actually, we are using the visuals from that orbiter in this mission as well. So orbiter means that will orbit around the moon. Okay. This is the moon. And this is the orbit of the moon. No, this will not be the orbit of the moon. This is the moon. And this is the orbit of the moon. Okay, so we have placed the orbiter here to take photographs, to find locations. So in Chandrayaan-2, we had the orbiter, the lander, as well as the rover. But what was the reason why Chandrayaan-2 failed? All those aspects we will discuss. But this is a very material difference of Chandrayaan-3 from Chandrayaan-2. That is, Chandrayaan-3 doesn't have an orbiter. It is using the orbiter of the Chandrayaan-2 mission. Now we are having only the lander and the rover. Then what are the objectives of the mission? Then why is the excitement? We actually landed. When did we land first on moon as mankind? It happened in 1969 itself, 54 years back. So in spite of that, so much progress has been made in the field of engineering, in space exploration. So before that also we landed on the moon. So why is the excitement? So we will deal with those aspects. Then it is a global mission in a way. There is global collaboration on it, and you cannot do it in a very nationalistic sense. Okay, science moves beyond boundaries. There is no boundaries of science. Actually, we have used information from NASA. Then the future missions, we are collaborating with Japan, the LUPEX mission for moon, lunar polar exploration. Some LUPEX is, lunar polar exploration mission. Then this is very interesting. Here we have the design is called failure-based design. Okay, why it is so? Because we have learned from the failure of Chandrayaan-2. Now it is not a success-based design. We will delve into this further. Then the significance of the South Pole. Why the South Pole? Or what is so interesting about South Pole? And South Pole came to news because in Chandrayaan-1, what did we discover? We discovered water ice on the South Pole. That happened in Chandrayaan-1. So it is a progression. It is not a standalone event, Chandrayaan-3. Then we will delve into the origins of the moon, how the moon came into existence, the Earth-Moon system that we talk about. Then what are the future missions? As I alluded to, there is the LUPEX. Then very shortly we will have the Artemis mission of NASA. Prime Minister Modi signed the Artemis Accords in his last visit to USA. Then we will look into certain aspects of ISRO. What are the positives? There is something called frugal engineering, which ISRO chief S. Somnath referred to in his press release, in his press briefing after the successful landing. So we will look into what is frugal engineering and why is it a good thing, or do we need to look beyond it? Okay. Then the challenges in rocket technology, as I briefly alluded to. Okay, and then what is the future of space exploration? Our common fantasy in our childhood was that we will see aliens in our lifetime, or at least we will move as aliens to other planets, something like that. So establishing colonies in extra other planets, like doing interplanetary missions, is now a reality. It is slowly becoming a reality. So all those aspects we will analyze. Okay. So mission to কি আছিলে আমাৰ Chandrayaan-3 mission to হৈছে যে there will be a lander. আৰু মানে মেইন অবজেক্টিভটো কি মিছনটোৰ অবজেক্টিভটো প্ৰথম যেটো আমি হিদিনাখন আমাৰ 23 তাৰিখে যেটো সাকসেস হ'ল 23 তাৰিখে আমি যেটো সাকসেসফুলি ল্যান্ড কৰিলো and for your information আপোনালোকে জানিব লাগে now it is declared as National Space Day. 23rd of August will now be known as the National Space Day. Okay. So we soft landed on moon. So objectives tinta asil mainly. Objectives number 1 was to soft land on near lunar south pole, and objective attained on August 23. Then the rover will rove. There will be roving. Rover will move out of the of Vikram, the lander, and it will rove. It will system is like here where Earth will from Earth we will contact with the lander, then lander will contact with the rover, and then signals will be sent. So it is like Vikram is controlling Pragyan while it is doing the experiments, and all data are actually many data are pre-fed. And be mindful of the fact that because of the vast distance, the communication has a time lag. So many information are pre-fed. So many things are happening, like you are seeing a lot of artificial intelligence in this also. Here also we have seen the photographs. The photograph that Pragyan clicked of Vikram. From that we could ascertain that roving is successful. Third, what will happen? What is the main objective? It will conduct certain experiments. So these are going on experiments. Spelling is wrong. So these are mainly the 3 objectives of the mission. Okay, then what is the significance? The significance of the mission: we have become the first country to land near the south pole of moon. Russia would have been the first, but unfortunately the lunar 25 mission it broke down just before the landing. So now we are the first. Actually, how many countries has soft landed? India is the 4th country to soft land on moon and first country to soft land on the south or near the south. So first it was USA, Russia, then went Russia or Soviet Union. Lunar 24 was the last mission. Actually, USSR, that time it was USSR. Then China did many in between, and now it is India. Okay, So this is the first significance. And secondly, as I referred to you right now, that it is no longer a fantasy that humans going up to space and setting up colonies. That is no longer a fantasy because of such successful missions. Now, since we are able to place a lander and a rover there, and possibly that creates an opportunity for other missions. Like we will see Artemis going there. Artemis mission is the mission of NASA in collaboration with many countries. India is actually not one of them directly, but India is a signatory to the Artemis Accord. So Artemis Accord is meant to create a framework for proper utilization of space resources, how space will be used, how we will do research, how we will bring in the private sector. So all those things will be covered under the accord. What was the earlier form of accord or earlier global treaty on space exploration? It was the Outer Space Treaty, signed during Cold War period. It had the backdrop of the Cold War because there was the fear that there might be space might be used as a weapon of war. Space war, we are very familiar with the series Star Wars and all. So all those had the presumption of a space-based warfare going on. So right now that threat is still there. How China is going, how Russia is going, it might be a possibility that we might see weaponization of space, but still we are creating a framework that will actually help in proper conduct of players in the space. Okay, so that is called Artemis Accord. And so there it creates the opportunity, that accord, and as well as this successful mission, it creates the opportunity for actually soft landing humans there or establishing colonies there. Okay, this is actually no longer it is a fantasy. You can say establishing colonies in exoplanets or in in outer space is no longer a fantasy. Now it is within our vision. It is within our touching distance. Okay, so that is the significance. And another important dimension we should see, why the excitement? Why the excitement? As I mentioned, in 1969 itself, that is 54 years back, we landed there. So what is so exciting? Actually, other than a few Chinese missions, neither Russia nor USA has been able to land, or they have not actually done the lunar landings after 1976. Luna 24 was the last one done. So it has been a long series, and there has been many failures. Failures is because of many technological factors, mainly technological factors, because you encounter different environment there. The geography is different. Gravity, that plays the most significant role, that is totally different. We know from our childhood memory that lunar gravity is 1/6 of Earth. So while descending, any module or any rocket, any satellite has to take account of that. All those things has to be there. So there is advanced computing, advanced mathematical calculations. So all those things comes into picture. Then there is no drag. Now while landing a plane in on Earth, you have the friend called friction. Friction helps in creating the drag that helps reduce the speed and helps in landing. But landing becomes very difficult on a lunar surface where there is no friction. So all those things makes the landing very difficult. And then communication, as I mentioned earlier, so you cannot have direct real-time communication with any vehicle on at such distance. So it creates problems for landing. So that's why we have seen huge failure. In fact, Sputnik was the earlier mission of USSR. There also they saw failures. Luna 24 was the last successful landing. Luna 25 recently failed. So that's why it is actually a big deal to have landed on the moon. It is actually a big deal. And so such are the challenges of landing a capsule in moon. Friction is very negligible. and gravity is very different. Because gravity is different, that's why friction is very negligible. So it is a very difficult task to land a vehicle there, and so it's a very significant achievement. And but still, we have actually gathered a lot of science from our previous missions. We have the samples from previous missions. Sample returns have taken place. Actually, many universities in the world have certain samples of lunar surface or lunar materials are there. Many have it. Now the science is very clear, and technologically, engineering wise, we are a lot more advanced. So these all things come into the picture of the success or the progress that we are making. Okay, so actually right now the next big thing that is happening, because it is a part of a global mission, the next big thing that is happening is Artemis mission. Here what will happen, there will be humans landing in moon. Humans will land in moon. What is the basic idea? If the water ice discovered in Chandrayaan-3 that can be explored further by the subsequent missions like Chandrayaan-3 and all. So if we have a water source there, it is not like we will be pulling water there to use in Earth. That is not the purpose. The purpose is, there are two purposes mainly. The first is to use it as a fuel for reusable rockets or the satellites there. You can use it as a fuel. Water can be used as a fuel. How? Hydrogen. This year it has been in news, the use of hydrogen as a fuel. We saw a couple of questions coming in UPSC preliminary exam also. So hydrogen fuel, it can be generated from water. Okay, and water can be used by those people, like they don't have to carry more water from Earth. So these two things can actually significantly alter, or it can actually realize the dream of creating a permanent base. Artemis mission's purpose is this: create a permanent base in moon, like we have base in ISS, International Space Station. So if we have a base at moon, so that will eventually propel us to go further. So we can think of having something in Mars or other planets. So this is a far-fetched dream right now, but still it creates the possibility. So that's why we have to think in global terms. Okay, so it will extend, or actually the knowledge of Chandrayaan-3 will help in Artemis mission. It will help realize those things. And here we are, the beauty of this thing is that here we are thinking of the whole world as one humankind. Not like India is having this knowledge or USA is having this knowledge. So that is the beauty of space exploration. It is at the pinnacle of scientific discoveries or scientific approaches that human beings are up to now. You can say basically artificial intelligence, biotechnology and space. These three are at the highest level. So this is one dimension of this mission. Then what do we mean by the failure-based design that we talked about? Failure-based design. So actually what happened is that in Chandrayaan-2, what happened was when the rover, the lander was approaching the landing site, its velocity was not to the optimum level. It was more. It could not reduce its velocity, and be mindful of the fact that we cannot control it from here. It will be fed information, and based on that, it will calculate and do the landing on its own in that regard. So its velocity was more, so it failed to land properly and it disintegrated at the time of impact. So now, how we have designed it, it's a very philosophical idea also. Like we have designed a failure-based design. Failure-based design, actually ISRO explains it as something which is not like a success-based design. It is like, even if, say, engine failure happens, even if, say, there is high velocity, even if there is algorithm failure, there is algorithms given to all the computers there. So even if those things are failing, even if you are failing to reach the landing spot, still the lander will be able to land at a location. And here the radius has been increased. Actually, the radius where the lander can potentially land, that area has been increased a lot. So it is actually a very good philosophy of life also. If we tend to make strategies based on like potential failures, like if this happened, then we can handle this way. If this happened, then handle this way, rather than being very optimistic about things. It will be fine, we'll be able to land. No, they were designed in a manner that, okay, if engine fails, then what will happen? Suppose some technical errors come in. Suppose some mathematical calculations go wrong. So that is why this is such a significant, event. It was a failure-based design. This was mentioned in the press release by ISRO. Okay. So here we are using the knowledge of Chandrayaan-2, and we are using the orbiter of Chandrayaan-2 also. Then, why the South Pole? What is so big? What is so significant about the South Pole? South Pole is significant because, number one, there was the evidence of water ice discovered by Chandrayaan-1. So it will help in further exploration, and as I have cited before, it will actually create the potentiality of creating permanent human bases in moon. Then secondly, South pole of moon is also called the dark side of the moon. And now I hope you know certain basic stuff. If you don't know, then be with me, I will explain you. Wait. One lunar day is equal to 1 year is equal to 14 Earth days in moon. Why is it so? It is so because the rotation of moon is equal to the revolution of moon. Means the time taken by moon, this is the earth, this is the moon. So the time taken, say this is the sun. So the time taken by moon to complete one revolution is exactly equal to the time taken for it to rotate itself on its axis. So what it creates is that one side of the moon is always not facing the sunlight ever. There is a permanent dark side of the moon. There is a famous Pink Floyd song on this phenomena, dark side of the moon. So there is always this, the sunlight never reaches there. So what is the possibility there then? So because sunlight doesn't reach there, the volatile material that is present there, or that was formed in the initial stages of its formation, that may potentially be there. And as we will learn further how moon was created, the dominant theory is the giant impact theory. There was supposed to be a big planet in the size, like not very big. It would have been the size of roughly the moon itself. Then it hit the earth, then it created the earth-moon system. So potentially there can be certain minerals of proto-earth present on that side of the moon there. So we can actually look into our history through the exploration of the south side of moon. That is why it is very significant. So it can potentially have the time capsule. বুজি পাইছে না কথাটো? মানে rotation কৰিবলৈ যিমান সময় লাগে, revolution কৰিবলৈ সিমান সময় লাগে। So হেতু কাৰণে কি হয়, এটা সাইড সদায় পোহৰ নপৰে। পোহৰ নপৰিলে কি হ'ব, তাত যিখিনি থাকে সেইখিনি সদায় ইনটেক্ট থাকিব পৰা পসিবিলিটি আছে। তো আমি যেতিয়া হেতু সাইডে চাইছো, তো সেই সময়ৰ যেতিয়া মুনটো ক্ৰিয়েট হৈছিল, চন্দ্ৰটো ক্ৰিয়েট হৈছিল, সেই সময়ৰ মেটেৰিয়েল কিছুমানো আমি এক্সপ্লোৰ পাব পাৰো। So it has immense possibility, volatile compounds কিছুমান পাব পাৰো। So early days of formation যিবিলাক আছিলে হেতু পাব পাৰো। So again, water is one factor, then এইবিলাক materials আমি খোজ কৰিলে, it can improve or increase our understanding of the moon, understanding of the earth-moon system. ঠিক আছে? So that is why South Pole is so significant. Then let's at a timeline আমি চাওঁ। Timeline to a timeline to চাওক আপোনালোকে। Look at this timeline. This timeline is it is a very, it's the timeline of our universe, known universe. Obviously, universe is expanding. We have had roughly 2 to 3% of the known universe we know, and that is itself very old. 13.7 billion years. In the crores, it will be 1400 crores. So roughly around 4.5 billion years ago, Earth was formed. This was the Big Bang event. Then Earth was formed. Then at this moment, what happened? The giant impact. There was supposed to be a planet, small planet here. It's hit Earth, and then the Earth-Moon system was created. So earlier it was thought that Moon and Earth is separate, but now we better understand these things, because Moon, what is the accepted theory? It is a natural satellite of Earth. It moves because along with that, gravity of Earth impacts the Moon the most. Like any artificial satellite is fixed to Earth. Why? Because it is impacted by gravity of Earth. Similarly, the Moon as a planetary body, it is impacted most by the gravity of Earth. That is why it's a natural satellite of Earth, or Earth-Moon system is created. মানে হিট হ'ল এতিয়া বুলি প্লেনেটটো ইট হিট দ্য হেৰি আৰ্থ। সেইটো সময়ত আৰ্থটো মল্টেন আছিলে, ত' সেইটো কাৰণে এইটো ভাবে যে সেই সময়ত যে আৰ্থৰ কিছুমান বস্তু, পৃথিৱীত থকা বস্তুবিলাক হয়তো এতিয়া মুনত লাগি থাকিব পাৰে। চ' সেইবিলাকত হয়তো সেই সময়ত যিবিলাক হেভিয়াৰ মেটেল থাকে, য'ত ডেনচিটি বেছি, সেইবিলাক তললৈ গুচি যাব। চ' আমি এক্সপ্ল'ৰ কৰিলে আৰু গম পাম এই সময়ত কি আছিল মেটেৰিয়েল এক্সচেঞ্জটো যেতিয়া হৈছিলে। প্ৰথমতে মল্টেন আছিল, এইটো Chandrayaan-1তে এইটো ওলাইছে ষ্টাডিত, যে মল্টেন মুন থিয়ৰী, যিটো যে অৰিজিনেলি ষ্টাৰ্টিঙৰ সময়ত এইটো আছে মল্টেন মাছ, তাৰপিছত চলিডিফাই হৈছে। দেন তাৰপিছত চাওক 3.7 বিলিয়ন ইয়াৰ্ছ এগো ফাৰ্ষ্ট লাইফ অন আৰ্থ, ফাৰ্ষ্ট অবভিয়াছলি এ চেলুলাৰ, একদম মাইক্ৰস্কোপিক লাইফ। তাৰপিছত চাওক 6 মিলিয়ন ইয়াৰ্ছতহে আমাৰ এনচেষ্টাৰ্ছ আহিছিল মানে কি, যে আমাৰ সেইটো একদম মানে উই হেড মেনি স্পিচিজ। তাৰ ভিতৰত হোমো ইৰেক্টাছ, হোমো কিবা কিবি, হোমিনিড বহুত কিবি আছিল ন, নিয়েণ্ডাৰথেল। আমাৰ এজ উই নো হোমো চেপিয়েন্স ইটছ জাষ্ট 3 লাখ ইয়াৰ্ছ। ইটছ চ' নিয়াৰ। তাৰপিছত আমাৰ যিটো চিভিলাইজেশ্যন, চ' কল চিভিলাইজেশ্যন বুলি কওঁ, যে কিয় চিভিলাইজেশ্যন মানে কি, হাউ ডিড চিভিলাইজেশ্যন ষ্টাৰ্ট? ইট ষ্টাৰ্টেড উইথ এগ্ৰিকালচাৰ। এগ্ৰিকালচাৰ আমি যেতিয়া মানে নেচাৰক অল্টাৰ কৰা আৰম্ভ কৰিলো, হিউমেন ষ্টাৰ্টেড টু চেঞ্জ অৰ ৰিশ্বেপ দ্য নেচাৰেল ৱৰ্ল্ড, ডেট ইজ হাউ চিভিলাইজেশ্যন ষ্টাৰ্টেড। এইটো জিঅ'লজিকেলি স্পিকিং এই পিৰিয়ডটোক হলোচিন পিৰিয়ড বুলি কয়, যে when human started impacting the atmosphere or the ecosystem. Okay, so তাৰ মানে হেৰিটো কি, চিমটমটো কি আছিলে, যে we saw rapid growth in human population across the globe. So এইবিলাক আমাৰ বিগ হিষ্ট্ৰী বুলি এটা টপিক আছে, বিগ হিষ্ট্ৰী টাইপৰ পঢ়িলে পাওঁ, যে ইউনিফাইড একাউণ্ট অফ হিষ্ট্ৰী, য'ত জিঅ'লজি, এন্থ্ৰপলজি, হিষ্ট্ৰী, ফিজিক্স, এষ্ট্ৰনমি চব আহে, কেমিষ্ট্ৰি। চ' এইবিলাক পঢ়িলে গম পাওঁ যে হাউ মানে আমাৰ এইটো কথা কিয় কৰো, মুনৰ ক্ৰিয়েশ্যনটো চাওক কিমান আগতে হৈছে, ষ্টিল আমিতো কিমান ওচৰত আছিলো। আৰু আমাৰ ইয়াতে আমাৰ মোৰ লগত থকা আমাৰ ফ্ৰেণ্ড ৰাজদীপে কৈছে এইটো কথা, তেওঁ এটা শ্ব'ত চাইছিলে। ৰাজদীপে কৈছে যে আমি যদি পৃথিৱীখন যদি ষ্টাৰ্ট হৈছিল 1 জানুৱাৰীত বুলি যদি ধৰো, তেতিয়াহ'লে হিউমেনৰ এক্সিষ্টেঞ্চ হ'ব 31 ডিচেম্বৰৰ 11:59:59। সিমান আমি নতুন হয়, আমাৰ এক্সিষ্টেঞ্চটো ইমান কম টাইমত আছে, তাৰ আগতে ইউনিভাৰ্ছ কিমান আগত আছে। চ' ইউ কেন ৱেল ইমেজিন where you are placed in the time scale. আৰু এতিয়া যেতিয়া আমি বস্তুবিলাক লৈ পেলাই মানে ইট গিভছ ইউ এ কাৰেক্ট পাৰ্চপেক্টিভ অফ থিংছ, যে এইবিলাকৰ ওপৰত আমি যে ৰিচাৰ্চ কৰিছোঁ কিমান ইম্পৰ্টেণ্ট হয়। এতিয়া বহুতে ক'ব যে বা এইটো এটা জেনুইন কুৱেশ্যনে হয়, ইণ্ডিয়া বিং এ ভেৰি socio-economically poor country, why should we spend so much? But again, this is not something we are doing as a country, it is what we are doing as a part of humankind. Okay, আৰু ইয়াৰ সাধাৰণ মানুহৰ ওপৰতো ইম্পেক্ট আছে। আমাৰ যিবিলাক চায়েন্স এক্সপ্লৰেশ্যন হয়, এগ্ৰিকালচাৰত ইম্পেক্ট কৰে, ৱেডাৰ প্ৰেডিকশ্যন হয় না, ৰিচোৰ্চ মেপিং, এইবিলাকৰ কাৰণেতো বহুত স্পেচ এক্সপ্লৰেশ্যন কামত আহে। ঠিক আছে, চ' সেইবিলাকো জাষ্টিফিকেশ্যন আপোনালোকে দিব পাৰে। ঠিক আছে। So এতিয়া তাৰপিছত আমাৰ এতিয়া নেক্সট ফিউচাৰ হোৱাট আৰ দ্য ফিউচাৰ মিছনছ মইতো কৈছোৱে আৰ্টেমিছ এটা লুপেক্স জাপানৰ লগত আছে। আৰ্টেমিছত লুপেক্সত কি হ'ব এইটো জাপানে এতিয়া এইটো প্ৰপ'জ ষ্টেজতে আছে, কনচেপচুৱেল ষ্টেজতে আছে। লেণ্ডাৰটো ইণ্ডিয়াই দিব আৰু ৰকেট আৰু ৰোভাৰটো জাপানে দিব হা। তাৰপিছত আৰ্টেমিছত ইউ কেন চি তাতে ৰকেটটো আকৌ কোনে দিব? এলন মাস্কে দিব। ৰকেট মানে স্পেচ এক্সেল ৰকেটটো দিব আৰু বাকীখিনি নাসা এণ্ড আদাৰ স্পেচ এজেঞ্চিজ। ঠিক আছে। চ' প্ৰাইভেট ছেক্টৰ কলাবৰেশ্যনৰ কথা আছে। ঠিক আছে, এইবিলাক হেৰি আছে। তাৰপিছত আমি চাওঁ যে ইছৰ এজ এ হোল, why is ISRO considered a big success story? There is one term that is used by S. Somnath, which is called frugal engineering. We are able to do massive things or such humongous things at very shoestring budget or ekdom shoestring budgetot ami eto koribo paro. Hardly amar there was this movie called Gravity that the budget of that movie was double of what the Chandrayaan-3 budget was. Okay, so what does it say? That we are able to send satellites or do space missions at a very cheap rate. So ISRO is renowned for its frugal engineering. We can do very cheap launches. So if you need to put small satellites like CubeSats or NanoSats, ISRO is the place to go. That is actually a well accepted fact in space market. And right now many private players are also there. Private collaboration, as I briefly referred to. We have a private launch pad in Sriharikota. Sriharikota, I hope you know that it is an island just across Andhra Pradesh in Bay of Bengal. From there we do the launches. And why? Another important interesting geographical fact. Why do we do the launches in Bay of Bengal? Why don't we do in the Arabian Sea? It's because of the rotation of Earth. So Earth rotates from west to east. Suppose something goes wrong, we want to ensure that the rocket falls in Bay of Bengal, not in, say, a city in India. Suppose you do in West Coast, possibility with the rotation of Earth taken into account, it may, if something goes wrong, then it can end up in mainland India. So having said that, such things are happening in ISRO, positive things are happening because it is able to do such quality missions at such a less cost, such a low cost. So that is increasing its credibility, but obviously challenges are there. We are not able to produce very high-end rockets, heavier rockets. Actually, one thing I missed, there is something called orbit maneuvering. You'll be surprised how long did we take the Chandrayaan-3, how long did it take from Earth to reach the moon? It took 23 days. But how long did the Russian lunar 25 take? It just took 6 days. Why? Answer is bigger rockets. Because it was bigger rockets, it could directly, this is the Earth, this is the moon, it could directly go there, take a straight route. But how do we go? Because we have to take the assistance of gravity. So we keep rotating till we get the sufficient speed, then we go there. Then here we'll again rotate, then land. So it is, the main reason is we cannot take huge amount of fuel. Because our rockets are smaller, we cannot take big amount of fuel, so we need to take such circuitous route. We do orbit raising, we do orbit lowering, so orbit maneuvers. These things happen because we are not able to produce. We don't have bigger rockets. Bigger rockets bring bigger fuel. We use cryogenics, we use liquid fuel. Liquid fuel, you can take a lot of fuel in a small amount, but still that proves to be insufficient to take direct route. Direct route, if we want to take, then we need more bigger rockets. So that is one challenge. Now again, what is the potential solution? I don't know if you have heard or not. There is something called 3D printed rockets. And there are reusable rockets. These are in news. These will potentially reduce the cost, potentially be able to carry more fuel, potentially be able to avoid the circuitous route that we right now take. So these are the challenges, or these are certain aspects of what ISRO is doing, how ISRO is actually achieving top pinnacle position in space research, and that is actually improving or increasing India's stature among the Committee of Nations. So it's a very significant, very epochal event for human civilization as well as for India. And what is the future? Future is obviously, we definitely see humans in space. We are going to see them soon. We have the Gaganyaan. Certain aspects of that are moving, but again, we will definitely see progress in this regard. And regarding other aspects to this field, like challenges, geopolitical challenge that may arise due to this space exploration, like say Artemis Accord is seen as a US-led accord, and it doesn't include China and Russia. So China and Russia are big players in space. So there, if we are not collaborating with them, then it can create a, you can say, a separate group, a separate, you can say, Cold War in space. So that is again political aspect that has to be managed at international level. But on the whole, it is a global mission. It is for global good. So it is something that will actually help achieve Vasudev Kutumbakam. Thank you.